I've climbed all the way up here to the top of the Wasatch Range to tell a very important story, the story about how mountains form, a story about how ocean basins form. It's called the orogenic cycle, or you can call it the mountain building cycle, or you can call it the basin forming cycle. But it's a way in which you can explain almost all of Earth's landforms. You can see that there's two major landforms here. There's a valley and there's all these beautiful mountains behind me. And you can also see that most of the rocks in the mountains are layered. How do you turn my hand? There you go, layered. Layered rocks are usually formed as sedimentary rocks, which means they were laid down on the ocean floor. These rocks behind me are actually made up, a lot of them are made up of limestones, which were produced by marine organisms. When you look at those rocks there, you can find that there's fossils in them. But what's strange is that even these tallest mountains behind me, Cascade Mountain and Mount Timpanogos, have fossils on the very tops of them in their limestone beds or layers. So was the ocean this high before? I mean, these mountains are 4 kilometers above sea level. So was there 4 kilometers of water all over the earth back when these rocks were formed, higher than what sea level is now? No. The sea level can only vary maximum by about 200 meters. Well, then how do you deposit all these sediments? Well, we can see places where the earth is being pulled apart. In fact, we can see it right here. You can see that basin right there. That used to be all mountains, part of the Rocky Mountains. But that part of the Rocky Mountains has been collapsing or being pulled apart for the last 20 million years. It's forming what we call the Great Salt Lake Rift Valley. You can see here that rivers pouring out of these mountains are depositing sediment in that hole. The thing is that part of the crust keeps sinking faster than it can be filled up with sediment. So in the process, you can stack up at least 10 kilometers. There's almost 10 kilometers of sediment in that basin. Well, you can also see behind me that if you start counting as you go up through the stack here of these sedimentary layers, you can almost get another 10 kilometers of sediment there. So there must have been another large basin similar to the basin we see here in the past filling up. Well, how did these rocks get up so high? Well, one of the most important parts of the orogenic cycle or mountain building cycle is illustrated right here behind me. See how these sedimentary layers, which were initially horizontal, are now tilted into a large fold? We call that an anticline. The way these rocks were folded is because after the sedimentary basin formed, it came into contact with another plate at a convergent boundary. So what happened was the sediments were crumpled like a rug. Now you can lift, if there's a 10-kilometer pile of sediments and you crumple them like a rug, you can lift them up high, as high as 4 kilometers above sea level. In fact, on the top of Mount Everest, there's also fossils from rocks that used to be at a seabed. And that's almost 10 kilometers above sea level. And it's still squishing as we speak. Well, the squishing of these rocks is over because now they're being pulled apart and that rift basin is forming. So the cycle involves opening up a basin so that you can collect sediments arriving at a subduction zone or a convergent boundary so that you can squish those sediments up into mountaintops. But then what happens is the sediments continue to squish up. Sometimes the plate configuration, instead of converging, changes somehow, which is what it did here in Western North America. And so the plate started to sink. Well, the crust above the plate did this. It pulled apart. And so this basin behind me is just like the space between my fingers. It's opening up. As it continues to pull apart the continental crust, which is like the fingers, the basin could eventually drop so low that it gets below sea level, like Death Valley is right now. As Death Valley continues to drop, eventually the water from the Gulf of California will come in and invade that valley, and you'll have part of California rifted away from the rest of North America. Here, it'll be this part of Utah right over here. You can see those mountains on the other side of this lake. As this continues to rip apart, it can become a new ocean basin. And then the cycle starts all over again. A new ocean basin provides a lot of space for new sediments to accumulate. Eventually that oceanic basin, because it becomes heavier and heavier the older it gets, will start to sink under its own weight. As it does that, it'll create a subduction zone. The sediments will then get crunched together again to form a mountain belt. The mountain belt will eventually collapse into another basin, and there you have the orogenic cycle, all in one part of the Wasatch Range.